You have seen a lot of logic thus far, and you haven't even seen the argument forms yet. That much changes now. Thus far you have looked at truth relations between propositions and how to express those truth relations. This is only the prelude to reasoning. The next step is comparing propositions that express various truth relations to one another. This is where you are able to draw further conclusions. Drawing propositions from a set of another proposition just is inference. It is the real work of reason. This video will look at simple argument forms. What I mean by simple is that these are about the smallest arguments you can get. They involve just two premises, and in one case not even that many. The complex arguments will come later. This video involves simple arguments using conjunctions and disjunctions. Don't be intimidated by the name of this argument form. It's really pretty simple. All it means is that from a conjunction you can infer either one of the conjuncts. From the fact that you are a student in philosophy and you are watching a video, you can infer that you are a student in philosophy. You can also infer that you're watching a video. For a memory mention image of conjunction elimination, I think of a chain breaking. Thus the links are separated just as the conjuncts are separated. Here's the form. We start with a conjunction. For our memory mansion image, we have our P's and Q ball and our hand. This represents P and Q in our memory mansion. Next, we simply infer P. We can also infer Q. Like I said, it's not nearly as complicated as it seems. The reverse of conjunction elimination is the construction of a conjunction. Just as you can infer both of the conjuncts from a conjunction, from any two propositions you can infer their conjunction. For a memory mansion image of conjunction introduction, I think of two chains being joined. Thus the links of a conjunction are being joined. Our first step is our first proposition P, represented by our P's. The second step is the second proposition Q, represented by our Q ball. From these we infer a conjunction. Now, all this looks simple-minded, but it is worth keeping in mind. You might be surprised when this can be important. That's it for conjunctions. Let's move on to disjunctions. Disjunctive syllogism uses disjunctions. Recall the subcontrary disjunction uses two assertions. We'll start from there. A disjunctive syllogism is a simple argument where one has a disjunction and the denial of one of the disjuncts. You can infer the other disjunct. The idea is simple. A disjunction represents that at least one of the disjuncts is true. We include that we know one is false, so the other must be true. For a memory mention image of disjunctive syllogism, I start with syllogism. To me, syllogism reminds me of a sill, as in a windowsill. So I have a windowsill. Outside the window, I have disjunct for disjunction. Disjunct sill for disjunctive syllogism. The form of disjunctive syllogism is easy enough to understand. The first step is our disjunction. We have our P's, or, and a Q ball for P or Q. The next step is to negate one of the disjuncts. This time I chose P, but it could just as easily have been Q. We infer the other disjunct. Here is disjunctive syllogism in action. Disjunctive syllogism for contraries works pretty much the same way. Recall that with contraries, our disjunction of denials expresses the idea that at least one is false. We include that we know one of the disjuncts is true, so we infer the other disjunct. Here we have our form. The first step is the disjunction of denials representing our contrary propositions. We include not only the ors, but our nots as well. Next we have an assertion. So we conclude the other disjunct, which is itself a denial. Here's an example of disjunctive syllogism with contraries. Here are the terms for this video. Memorize these terms and how to construct these arguments off the top of your head. That's it for simple arguments with disjunctions and conjunctions. Next we have simple arguments with conditionals and biconditionals.